Hello everyone, my name is Vedant Singh and today we will be presenting how to make your own custom dataset class. So in order to begin with how to create a custom dataset class, it is very important to import certain important packages and dataset structures such as NumPy, Pandas, and Torch. So we will quickly go through different dataset structures in order to understand dataset class more efficiently. To begin with, one of the most commonly used dataset structure to load datasets is NumPy. We usually save it as an NPY file, and in order we can load our datasets from the NumPy NPY file. Then we have our Pandas dataset. Now, the Pandas library is not usually used for datasets in our homeworks. However, we use Pandas for, say, inferring results from a CSV file or saving the results into a CSV file for our Kaggle submission. Now, as we can see that pandas data frame usually uses the key and value dictionary as structure. So we need to assign a value to each key as done in this example. We can then save the table into a CSV file. We can load the CSV file, etc. One of the most important dataset structures is the tensor dataset type. PyTorch adopts the default 64-bit integer data type from Python. We can access that using the D-type tensor. We can also create PyTorch float tensors using the 32-bit precision. One thing is very important for everyone is that we need to maintain consistency throughout our model between 64-bit precision and 32-bit precision. So, and because sometimes if you're not consistent, then it throws an error. And secondly, if you guys are facing out of memory issues, it is recommended that everybody uses 32-bit precision and 32-bit precision so that out of memory issues do not come. Now, some common PyTorch tensor operations are that, say we have a 2D tensor and we want to know the shape of the tensor, we use the command such as dot shape. If we want to, say, reshape the tensor, such as we want to reshape it into any other, like transpose it from 3, 2, we have two commands for that, dot reshape and dot view. Now, if we just want to use the transpose the current array or a current matrix into it, the command is as similar as to a NumPy array, which is using dot .t. Now, one of the most important operations that we use for neural network development is using matrix multiplications. So in tensors, in order to do that, we use the commands such as matmul or @. This utilizes all the laws of matrix multiplication, and the key difference is that students usually get confused between matrix multiplication and element-wise multiplication. And matrix multiplication follows all the laws of matrix multiplication, and element-wise just multiplies one element with another. Now let's go on to understanding the PyTorch dataset class. The pipeline looks as follows, where we initially pre-process the data by collecting it, cleaning it, and then we transform the dataset class using three essential functions, the init, length, and getItem function. This is then loaded onto the data loader, which then the data loader goes back to the dataset class to retrieve another batch of dataset. And this is how the cycle goes on, and we pass it on to the model. Now, like I mentioned, the three functions are essential for the dataset class. The init, which is constructor function, the length, which essentially just returns the length of the dataset, and the getItem function, which is used for retrieving individual information, for performing transformation on the batches, etc. Now, we can optionally, define a collate function also if needed as as a way for transformation of a dataset. But that is something we will cover in data loader class recitation video. There are some FAQs that I would personally suggest you all to go through, which answers most of the dataset class questions. Now, moving on to now making our own dataset class. So like I mentioned that we need to create our own dataset class. So let's create our own dataset class and inherit the parent function from PyTorch dataset. Now, let's define our first function, which is the definition of init, which we will self, because that's how the class and functions and object-oriented programming works. We will define two arguments, x's and y's. All right, so now that's how this is. Now let's see. So we first define our x's, our y's, and we define the length of the dataset. So what we need is that, yes, this will now return the length of Rx. That's what we need. All right, then we move on to defining our len function, which is only dependent on itself. So we return simply this length of the dataset. Finally, we define our get item function and the index. So essentially what we want at this point is we want to return the item at a given index. Okay, so what we're going to do is we want to return the X at a particular index, and we're going to return a particular Y at a given index. Perfect.